Some cosmologists use spectral lines to measure redshift, but they may not be an accurate determination of the nature of light. In the spectra of some objects, one has found several systems of lines with somewhat different redshift z. Andreas Anderson. Also, in regards to the calculation of redshift using spectral lines that some cosmologists use, quote, astronomers talk about redshift in terms of the redshift parameter z. This is calculated with an equation where lambda observed is the observed wavelength of a spectral line and lambda at rest is the wavelength that the line would have if its source was not in motion. Unquote. Cumbres Observatory. Given that some wavelengths are absorbed in the ether, absorption line spectrum are atoms with a certain gas absorbing some of the colors, making them have black spectral lines. Different gases or groups of atoms emit different spectral lines. Whether you are referring to a light in a prism, different gases that create absorption lines or refraction of light due to hydration, such as a rainbow, spectral lines would not explain a redshift phenomenon of light moving away. Although conceptually spectral lines are the same when referring to a prism, gases, and rainbows, they would have no impact on distance functions, and one could not measure them accurately. For example, a rainbow with a certain amount of emission lines would be fundamentally different and have different frequencies than starlight moving away from an observer. Furthermore, the distance to the mirage at the end of the rainbow keeps moving away the closer you attempt to get it. The saying you can't find a pot of gold at the end of the rainbow definitely holds true in this respect of distance. As any distance functions are impossible to read clearly on the basis of spectral lines. The same is true when you apply this logic to gases and prisms. The radar gun is clearly sound evidence that frequencies can be changed and the speed, direction, and location of objects can be deduced and measured. For example, the radar gun has a rest frequency in which it uses as a baseline measurement, then takes a frequency from a moving body, and so it therefore detects speed of that object. A LiDAR gun sends incremental pulses at the speed of light to the object. They bounce off and go back into the contraption for accurate readings on speed. However, given long distances such as distant galaxies, their accuracy can come into question. The farther away they get, the more they lose their accuracy because of lack of their signal coming back to the device. In the case of radar, the frequency can be perturbed by many different variables that, if applied to stars, lead to a lack of accuracy over the course of many light years. A star is also characterized by its luminosity distance, which is defined in terms of relationship between the absolute magnitude m and the apparent magnitude m of an astronomical object. In order to correctly calculate a star's energy output, you would need a star radius, star temperature, luminosity, absolute magnitude, distance, apparent magnitude, and surface brightness to get an accurate reading. A justification of these factors are necessary for accurate calculations. These variables are hard to record. There could be large error factor involved in measurements of these celestial bodies. These initial luminosity measurements that the whole system is based upon can be skewed when your initial measurement is basis for the next metric and next measurement, and so on until all measurements are dependent on each other's observations to get a readable distance. If each of these measurements is also dependent of the speed of light, which clearly has many different values, then starlight's energy and distance, and hence the age of the universe, can and should be questioned. Current cosmological measurements of redshift, in which a ground telescope are used, shows a primary measurement of stars and their light, followed by secondary measurements of stars and their light. These measurement calculations would show a star to be redshifted and deduce that the galaxies are moving away. However, in practice, with the notion of the Earth and its parallaxes, the notion and predictability of location of distant stars by a shift in frequency and wavelengths can also lead to inaccurate readings of starlight because of motion, both progression and recession of the star's constellations' relationship to the Earth. If one does not know daily rotational or seasonal rotations of the distant stars, then one may not be able to judge the characteristics of a star. Along with distant galaxies, one would have to account for daily rotation and seasonality to take into account the presumed observation of a redshift. Redshift and blue shift cannot be attained in any experiment on Earth besides the gravitational variety. It is true that the closer the light source gets to you from something like a moving vehicle, the brighter it becomes, but it certainly does not blue shift, and if moving away does not redshift. Say you have a 60-watt light 3 meters away and the other 40-watt light half meter away from a detection device. Say they are both moving at constant rates. If your detection device registered a greater luminosity on the 40-watt light bulb half meter away and decided based on a calculation fallacy of light speed that the 40-watt light was brighter than the 60-watt light, then something is incorrect in your experiment. This scenario could play out in cosmologists' measurements of distant light sources at rest and moving away. Another potential experiment that could prove to be incorrect could be done with either high peaks on a clear day with large visibility or ships on an ocean that could send light across great distances and observe if they redshift or blue shift in travel. I have surmised that redshift, in fact, an observation that many cosmologists have recorded having seen, may not retain all of the nature of light in space. Edwin Hubble took this insight of the cosmos and deduced a theory of cosmic expansion that showed redshift in starlight calculations. From that, he was able to create the Hubble constant, and he measured higher velocities in longer range distant galaxies that they still use today. Galaxies displaying higher velocity show the greatest Doppler effect, according to NASA. These observations are hard to argue with, as Edwin Hubble has recorded many known multiple star points moving away from each other, seemingly expanding with space expansion as evidence of the Big Bang. There have been many reported observed redshifts that are almost always related to line of sight velocities associated with the objects being observed. Looking out into space, there's an infinite vastness and a need to adopt alternative independent arguments and deductions contemporaneously to the ongoing arguments of cosmological community to facilitate a culture of looking for a new truth in cosmological discourse, and to try to uncover the realities of nature in its origin and age. There is a possibility that many frequencies and wavelengths feature to their intrinsic value, allowing them to show a redshift when they may not be receding in terms of distance. They show this redshift by gravitational bodies directly behind or in front of the emitted light, like the concept of dark energy, causing the perceived wavelength to change. However, there must be an introduction of a non-constantality and non-redshifted viewpoint of light in which their frequencies and wavelengths need to be accounted for as separate from each other and measured in variety and classification. There is a possibility that a more infinite universe of mass creation converging with areas that represent steady-state theory cosmology that may one day lead to breakthroughs and explain the universe in entirety. It is my goal to show evidence of both in an all-encompassing, streamlined mathematical framework. In summation, about the concept of redshift, it is a novel ability used by the leading cosmologists to predict and measure galaxies that are moving away from observational bodies. In that deduction lies a theorem in which it is responsible for the leading cosmological assertions in the 21st century. That ability is hindered by innate constructs of light that cannot be accounted for in the realm of cosmology. Those constructs of light, unlike their speed, have an innate ability to go unchanged when broadcasted over long distances. The rigid, unperturbed nature of a wave, both the internal picture captured in television and audio captured in radio waves, as well as the lack of wavelength adjustments between still and moving bodies without an adjustment from the emitter, leads me to question these pillars of cosmology. Describing a cosmological world with no redshift has great impact on the conventions of science. The ability to know and understand stars' distances has direct correlation to knowing what is in us all, to confront the deep questions about where we came from.